All right, so we are recording. You get all real numbers for that one. And now the second one, and so let's take a look. And we haven't verified, this one's right. I haven't verified the second one, but distribute -5 times -2, positive 10. Really important there. And then we take 10 plus 4, and that's where he gets the 14. So everything looks good so far here. Add 5y. Now, did anybody add 3y instead of 5y? Okay, you still get the same answer. Okay, it'll look a little bit different. That's okay. But you get 14 is greater than or equal to 18 plus 2y. Subtract 18, we get -4 is greater than or equal to 2. Divide by 2, which is -2. And you have to put the y first, or the x first, or whatever the variable is. So y is less than or equal to -2. That is your final answer. Okay, that is your final answer. All right, Mr. Schler, so we need to go over 55 on the homework. We will talk about the others as well, but 55, here's what it says. 3/4 of a number. 3/4 of a number is greater than or equal to 5 less than the number. 3/4 of a number is 3/4 x. That's all you got to do. Is greater than or equal to, okay, and then it says 5 less than the number. All right, how do I write 5 less than the number, Christian? It's got to be x minus 5. It's got to be x minus 5 for that one. Now, there's a couple ways to solve this, but here's what I would tell you to do. Get rid of that fraction by multiplying everything. What can we multiply everything by to get rid of that fraction? 4. Now, when I say, and I saw in some of your papers you did a little bit of it, but you got to multiply each term. Because some of you didn't multiply that x. Well, what happens? What is 3/4 times 4? 3/4 times 4 is 3. 3x. 3x is greater than or equal to 4 times x. You got to multiply that 4 by the x minus 20. And then you subtract 4x. You never want to clear out a side. You never want to move that 3x and give you nothing on that side. Because -1x is greater than or equal to -20. But Josh, what do I still got to do?
Divide -1 on both sides.
And then what happens when I divide by -1? You flip the sign. This becomes, instead of greater than or equal to, less than or equal to 20. Okay, that should be your final answer. All right, now for your rest. I even put it down so you got all the work and everything because this is an important one. So take a look at what you got. 20. And I'll leave this on the class notes. So if you go to Canvas and you go to class notes, this will be one of the slides. You got x is greater than or equal to -4. We divide by -2. We flip it. Greater than or equal to, shade to the right. 28, I got n is less than 6 for my final answer. And for 32, I got n is greater than 3. All right, you're going to just have to go to Canvas and get the rest of those. So you have time to just copy those. Okay. All right, so 32, again, x is first, n is first, n is first. Okay, you got to write that. All right, what is the next one? 36, anybody got an answer for 36? What do you got, Zach?
There's no answer.
Oh, he says no answer. Let's see if he's right. No solution. All right, that's a false statement. I get 5 this is a case just like the bell work. 5 is greater than or equal to 10, no solutions. 5 is not bigger than 10. Y is greater than or equal to -4. For number 40, dealing with some distributing, combining like terms. All right, now I even tell you what to do for 44. Everything has denominator 5. If I multiply everything by 5, okay, it clears all those out. I end up with, when I'm done, x is less than or equal to 4. Proof for that. And then was there, how many more? Was there just 2 more?
Yeah.
All right, 53 was a word problem and 55. 53, again, I think it uses 10 less than 5 times a number. 10 less than 5 times a number. Yeah, hold on. So when you got this, 10 less than, this is where you order flips. 5 times the number is 5x. You got to make that 5x minus 10 is less than 6x minus 8. And then when we're done, we end up with x is greater than negative 2. Sam?
For number 36, I did it completely a completely different way, but I still got the same answer.
How did you do it?
I did the top part right, like negative 5k plus 5.
Okay.
But then I added 5k. I got negative 5 is greater than or equal to 10. I don't know how I got that.
Okay. So here's the only thing I can think of is that when you distributed that negative 5, you didn't make that a plus 5. You kept it a minus 5. Okay. And so when you did that, you happened to get the same, since when I add 5k, you get negative 5 is greater than or equal to 10, which isn't true as well. So you said no solutions. The only thing you got to watch, like if that was, if this was a different number, it might not be right. But it looks like you didn't, negative times a negative is a positive. You didn't make it a positive, okay? And for 53, like 10, this is probably the biggest mistake. I'm sure a few of you have 10 minus 5x. Okay, that still keeps coming up. But anytime you get 10 less than, you got to subtract 10, and then 5 times the number is 5x. And then we did 55, which is again here. So I'll have this on Canvas as well. I mean, it'll just be part of the class notes. I think this is going to be good just to kind of, especially if you were absent or if you need to go back and fix a few. All right, we got one last section, section 3.6. We'll review a little bit tomorrow, we'll review a little bit on Wednesday. We will have a test on Thursday, and I think it is an 80-point test. And we'll give you guided notes, but before we do that, I want to see if you can figure this out. You can do this right on your homework as well. All right, write 10 real numbers that are greater than 2 and less than 6. Okay, we need to come up with 10 different numbers that are greater than 2 and less than 6. All right. This is Jay Lee. Can you give me one?
Me?
Yeah.
3.
3. Yeah. Is 3 bigger than 2? Is 3 bigger than 2? Yeah. Is it less than 6? All right. 3 works. 3 definitely works. Joe, can you give me one? 4. 4 is bigger than 2 and less than 6. We're on a roll. Okay. Connor. 5. All right. Now it gets a little tougher. Now it gets a lot tougher. Joe. 4.5. 4.5. All right.
Oh,
Well, maybe we cleared that hurdle. Maybe we cleared that. Caitlin. 3.5. 3.5. Okay. How about from there, Joe? 2.5. 2.5. Hanan, what do you got? 5.5. All right, how many numbers could we list? A lot. A lot. What's a fancy math term for a lot?
7.
7?
7 of them? Or are you saying the number 7?
No, there's just 7 of them.
I think I can list more than 7, I think.
No, there is 7.
There is 7 up here now, but how many could we list?
Well, apparently we have to.
You said do 10.
At least 10. Can I write more than 10?
Yeah.
All right.
But there's only 7 up there.
Okay, so I could do 5.1. I could do 5.2. I could do 5.3. I could do 2.1, 2.2, 2.3. We could have a contest so you could list them up.
Yeah, 40 different combinations.
40? I can do more than that. Yeah.
I guess it's
Yeah.
Oh, there's infinite.
3.1 will work. There's what? What is that word?
There's too many.
There's too many. There's infinite.
That's
Ooh, I know one.
infinite.
Pi. Hey, we could sit here forever and list them. Okay, there's an infinite number of points between 2 that are greater than 2 and less than 6. So you just need to start with 2.1, 2.11, 2.12, 2.13. But we could do it. Now we don't need to list all 10, but can you give me 10 real numbers greater than 6 or less than 2? Or less than 2. So Morgan, just give me one.
7.
Oh, 7. That'll work. Okay, Josh, give me another.
No.
8. Colin, give me one.
1.35.
1.35. Okay. Will there be more or less numbers here? Potentially. But how many did you say we could list here? Infinite. How can you have more than infinite?
Infinite plus 1.
But then I add 1 to that. So, all right. So we can list a bunch. So I want you to think about this. Let's graph all the real numbers greater than 2 and less than 6. What would that look like? You just listed about 10 of them. But what would all of them? How can I graph the greater than 2 and less than 6? So think about this. It would be this number here, bigger than 2 and less than 6. It would be everything in there, right? Okay. So 2.1, 2.2, 2.3, 3.1, 3.2, 3.3, all those numbers. So in between there would work. What would all the numbers greater than 6 or less than 2 look like? What would that graph look like? Has to be greater than 2, right? Or greater than 6. And what does the graph for less than 2 look like? Open circle shaded to the left. So all of those numbers, so the key word is or. Okay, it doesn't have to satisfy both. It can just be less than 2 or it could be bigger than 6. Doesn't have to be an and. The other one here said it had to satisfy both. It had to be bigger than 2 and it had to at the same time be less than 6. So we had to cap, we had a bottom number, we had a top number. Okay, these are called compound inequalities. Okay, these are called compound inequalities, and let me give you your guide number. All right, I got over here that. Okay. And let me go back over here. What you can do. All right, and this isn't on your guide notes. Just pay attention. Josh, quit bugging. You could say 2 is less than x is less than 6. That's the same thing because x, if you read it this way, is bigger than 2 and x is less than 6. That's the only time we can kind of combine two things at once. So if you have that, you're saying x is trapped between 2 and 6. For this one, the only way we can do this one is I got to say x is less than 2 or x is greater than 6. So if it's trapped between two numbers, I can trap the x between two numbers. So take a look at what it has here. That's what we just talked about. if x is greater than 2 and x is less than 6, it's going to be trapped between those two numbers, and I can say 2 is less than x is less than 6. Okay, that's that chart at the top. Now, if they throw the equal to part into it, it's no different except you got solid circles. No different. But if you're going different directions, you can only do that with the word or. X is less than 2 or x is less than 6. And then x is less than or equal to 2 or x is greater than or equal to 6. Okay? Compound, because basically got two things going on. These are all the numbers bigger than 2 and less than 6. We're going to skip that one. That's the one that's not on there, is it? All right, so they talk about here. I got the same thing.
I don't think so.
No, I forgot about that. That's not the same thing. But just take it we are going to look for the overlapping region. And so here's what's going on. And we're not going to do this on every one. I just want to show it to you on this one. So x is, let's see, this is -3, -2, -1, 0, 1, and 2. Whoops, what did I mess up? Hold on. -1, 0. All right, x is greater than -3. All those numbers are right. X is less than 2. All those numbers are left. If it's an and, we want to find out where they overlap. Well, where do those two graphs overlap? And that's our final answer. So you can slide this down, and they're going to overlap between what two numbers? Between -3 and 2. So our final graph will be between -3 and 2. Because technically that's where those two overlap, okay, in between those two numbers. So those are all the numbers bigger than -3 and less than 2. All right, just pay attention to this one. Here's what it's going to look like. We want to get the x by itself in the middle. Well, how do you think I get that x by itself in the middle? Okay, what do I got to move? I got to move that +1. What do we always do, just like before? Subtract it. But now I got to subtract it underneath the 1, and I got to subtract it over here, and I got to subtract it over here. But once we get that, we're done. And then the final answer is going to be between -6 and 1, just trapped in between there. So if I plug in any of those numbers, it'll make that true. So we're going to add in that more than just an x in the middle there. All right, I think this is the one on your graph, right? Okay. -7 is less than 3x minus 1 is less than or equal to 11. Move the 1 first. Move the 1 first by putting +1. Okay, now, -7 plus 1 is -6. Is less than 3x is less than or equal to 12. Now, I still need to get x by itself. So how do I get rid of that 3? Divide by 3. Now, when you divide by 3, though, you got to divide. -6 by 3. You got to divide 12 by 3. All right, now I don't think we need to do this as two cases, but just want to make sure you understand. This is what it's saying. -2 is less than x. That's the same as x is greater than -2, and x is less than or equal to 4. You just have the one graph on yours at the bottom, right? Yeah. All right, don't worry about doing all three of these. Okay, because here's what's going on. I got -2, -1, 0, 1, 2, 3, 4. Go ahead and label your graph at the bottom. Now, how are we going to shape? Zach, what do you think?
So at negative, so you would have like a hollow circle.
Okay.
And when you, and then going forward, we have a solid circle.
Solid circle there, good.
And when you graph them together.
So basically you are shading in between them. Yep. Those are all our answers. From -2 to 4. So if you plug in any number there, it's going to make that true. So if I plug in the number 2, 3 times 2 is 6. 6 minus 1 is 5. Is 5 bigger than -7? Yes. Is 5 less than 11? Yes. Okay, so trapping it between -7 and 11. Okay. So we really only need to worry about that one equation, or that one graph. All right, the one next to it says solve the compound inequality and graph the solution. Same idea. Evan, what do you think we should do first?
-5.
Good. -5 from the right, the middle, and the left. Okay, that gives me -9 is less than or equal to 3n is less than 6. And now divide each piece by 3. And that gives me -3 is less than or equal to n is less than 2. All right, again, we're just going to do the one graph. So just label it at the bottom there. Make sure you can get all the way from at least -3 to 2. And now, -3 is less than or equal to, which means there's a solid dot at -3 to +2, shade between. Okay, shade between. So just do that on the bottom. All right, once you have that, you can flip that over. Okay, or is the union. Or is the union. So you see at the top. Means you combine them together. You're not going to have any overlapping. You want to take all the answers from the first one. So this is x is less than 0, and that's x is greater than 10. All right, is that the same one you got on yours? Yes. So all the numbers that are x less than 0 or greater than 10 are going to end up going the opposite directions. And the only way that can happen is you use the word or. It says the word and, it has to work for both of them. But in this case here, I can have them end up in opposite directions. You cannot, it has to be written as 2 different inequalities. So take a look at that first one there. I got 8 plus t is greater than or equal to 7, or 6 plus t is less than 2. There's absolutely no way with an or to make it into one case. So just solve them separately. Well, for the first one, you just subtract 8. You get t is greater than or equal to -1. The other one, you subtract 6, and I get t is less than -4. Key word here is the word or. Just graph them both. Just graph them both. Okay, for right now. So make sure your number line, okay, goes far enough. I'm going to go -5, -4, -3, 2, -1, 0, 1, and 2. Greater than or equal to -1. Solid dot at -1. Shaded to the right. Less than -4. Hollow dot on the -4 shaded to the left. Both of those are our answers. Leave that. Okay, because it just says the word or, then you're good. Make sense, Preston? Good. All right, you got another one there to the right? All right, solve the compound inequality and graph the solutions. Okay, you got, again, 2 cases, 2 little inequalities. The first one says 7x is greater than or equal to 21. Well, to solve this one, divide by 7. It's not a negative number. Don't flip your sign. X is greater than or equal to 3. Or divide by 2 on the other one, and I get x is less than -1. Okay, let me see here. I got -3, -2, -1, 0, 1, 2, and 3. That's enough to get both of those. All right, x is greater than or equal to 3, solid dot at 3. To the right, less than -1, hollow dot to the left. So I got him going in two different directions. Two different directions for the word or in this case. All right. Now, let's kind of go the opposite. It says, write the compound inequality shown by the graph. Okay, is that the same one you got? -8 to the left and then 0 to the right. Okay, how could I write that as a compound inequality? Zach?
X is less than or equal to -8, or X is greater than 0.
X is less than or equal to -8 or X is greater than 0. Yes, the only way you can write it is with an or, two separate inequalities. And then here's a little bit of a clue, is his shaded portion of the graph is not between two values. So the compound inequality involves or. The only way you can describe this is you got to describe both of them. X is less than or equal to -8 or X is greater than 0 or X is greater than 0. Oh, I think it just froze on me. Typical. All right. We'll take a look at that next one. See if you can figure out what that is. Why unfreeze here. Okay. Is that the one on your graph? All right. Write the compound inequality shown by this graph. Zane, any ideas?
Yeah.
We got
X is greater than -2, or X is less than 5.
Okay, he's close. He's close. Okay, Joe?
-2 is greater than X. This way. It's less than 5.
That's what you said there.
Yeah.
All right, he's close too. They're both close. Zach?
Exactly the same way, so it'll be -2 is greater than X, and then greater than 5.
No. No. Now think of this, Zach. You just said X is greater than 5, right? Is that showing up there? No. Okay, here's what it is. So hopefully you didn't write those down. Fix it. -2 is less than X is less than 5. Okay? Now, let's go back to Zane's. How can I fix Zane's? Because he's really close. He's got one key thing wrong. You could write it this way, except you cannot use the word or. It would have to be the word and. I would accept either one, but I'm telling you, I think this one's better and easier. Okay, I would write it anytime you got it trapped between two numbers. Just start with the first number. Because what is that saying? And I know I've always preached to you, write the X first, but we can't do that when I trap it between two numbers. So you got to understand what this is saying. It's saying -2 is smaller than X. Well, what's the reverse of that? That means X is bigger than -2, right? Which these numbers are bigger than -2, but what also are they? They are also smaller than 5. So you want to start with the smallest number here, the biggest number there, and you want both signs to be less than or less than or equal to if it's a solid dot. Okay, so you can do that, and I would just write it like that. That's an and problem. That's saying, just like Zane said, that's saying, all right, these numbers are bigger than -2, and They are less than 5. Okay, but it is the exact same thing for that. All right, page 206. This is the last section of